Materials for this video have been recorded before significant political changes have taken place in Bolivia in November 2019, which have led to abrupt changes in the management of the country's lithium industrialization project. We provide materials in their original form with the updates at the end. Bolivian lithium industrialization and their partnerships. In Bolivia, under the current government of Evo Morales, who was the first indigenous president, lithium is considered a strategic natural resource. According to the Bolivian Political Constitution and Mining and Metallurgy Law No. 535, the state has certain duties regarding lithium. It will administer lithium resources in function of the collective interest. Brines are reserved for the government. The basic chemistry processes of evaporitic resources will be assumed with a 100% state participation. National or foreign private companies may participate through association contracts, maintaining the majority participation of the Bolivian state only at the semi, full, and value chain industrialization and at the residual brine industrialization. This course will focus on the recent Bolivian lithium industrialization from brine deposits, and it will describe the public-private partnerships.
In which phase of exploration is Bolivian lithium currently?
Currently, we are having trials with potassium chloride, the first industrial product. We have completed an industrial unit since August, which will continuously produce 350,000 tons of this fertilizer for the Brazilian market. I would like to remark an important decision, which is that Bolivia will industrialize its lithium, breaking the extractivism scheme. Our country doesn't want to only produce lithium carbonate, lithium hydroxyl, or potassium chloride, or other salts. We would like to get to the final product to aggregate the most value to our resources in the industrialization chain. So, from the raw materials, we obtain basic salts, such as lithium carbonate, etc. Our goal is to convert these products into a value-added product, such as batteries. As a pilot project, we concluded the industrialization circuit of Bolivian lithium. We started with a pilot lithium carbonate plant that achieved battery-quality lithium with over 99.5% purity, certified by the CEA, the French Alternative Energies and Atomic Energy Commission. We also have a pilot unit of cathode materials, where we synthesize cathodic materials, which is the battery's main component. We are currently incorporating Bolivian lithium into different types of cathodes through different methods, such as NMC, which is nickel, cobalt, manganese, and lithium, LMO, lithium manganese oxide, and in the chemistry of iron, lithium cathodes. We are using lithium extracted from the Uyuni salar. With these materials, we are assembling batteries. So, we have closed the circle at a pilot scale. However, we are jumping into an industrial scale. The first industrial unit I mentioned is the potassium chloride. Then, the lithium carbonate unit, which will start construction next month, and so on, so that we can complete our plan to finally start production of batteries in Bolivia.
Please explain the public partnership alliances throughout the production chain.
Bolivian legislation has declared lithium strategic due to its current importance in terms of energy, but also because of the role of lithium in nuclear fusion. So it is a strategic resource for Bolivia. The company that will bring this industrialization process forward is the Bolivian State Lithium Deposit Company, YLB, which stemmed from the Bolivian Mining Corporation as National Management Resources. We have the capacity to industrialize and to treat residues. Although Bolivian legislation establishes that the production of lithium salts are to be exclusively exploited by the state company, there is the possibility of association with specialized companies, with YLB holding at least 51% and the strategic counterpart 49%. Other pre-established conditions require that YLB must select counterparts with cutting-edge technology and permanent innovation. Another condition is that the strategic partner has to guarantee the market for the batteries assembled in Bolivia. Lastly, a potential strategic partner associated to YLB must agree to treat industrial residues. We have been meeting with several international companies, 8 of which presented proposals, and we selected ACI Systems, a German company. We started all the pertinent documentation to achieve this association. What is the goal? To produce batteries in Bolivia with the standards of electric mobility required in Germany, and with the standards required by alternative energy products, producing lithium carbonate and lithium hydroxide from the residual process, about 25,000 tons. This product will be used in the cathodic materials and the battery unit. The capacity will be 8 gigawatt hours, being one of the main battery factories in the world.
Could you comment about the recent possibility of an association with Russia?
Well, we continue to have interest from Russia, China, and Canada to advance in a strategic association to add value to our resource, but in parallel to the agreement signed up with the German company. An important fact is that the Uyuni Salar is the largest in the world, but we would like to consider other salt flats, such as the Salar de Coipasa in Oruro. This has been considered in the negotiation. Russian, Chinese, and Canadian companies are also interested in other salts.
Does YLB have any patents to extract and process lithium?
Yes, we have about 12 patents registered in the Bolivian Patent Registry. There is an important competition among different countries in the lithium industry, especially by Chile, who is objecting to some patents. For example, lithium sulfate, the most important one, which is processed by solar evaporation in open pools to concentrate it in lithium chloride to obtain lithium carbonate. Our goal is to reduce the magnesium-lithium ratio to obtain more lithium. Researchers actually think it's currently difficult to achieve that.
Critics say that $450 million were invested in the 3 phases, but less than 100 tons of lithium salts were produced at the pilot plant. Critics think that this was not an appropriate moment to have signed a contract with the central bank.
The ones who criticize us don't understand what goes on in the research of the pilot plant. The pilot plant is a larger laboratory to simulate processes. Before an industrial scale, these processes require a previous step at a larger scale than a laboratory test in a pilot unit. A pilot testing unit is another necessary step or phase in the research process to optimize and improve the process, controlling and calibrating the variables. Once all the variables are tested and verified, we can take the next step into an industrial scale. It would not be responsible to go from a lab phase into an industrial phase due to the investments required and the tests needed to verify the process. Our pilot units were tested and accomplished that function. We applied, improved, and learned the conceptual engineering with the pilot, and the natural next step is to develop the final industrial unit. A pilot plant's function is to consolidate the research process and full proof of the process. It doesn't have the objective of selling a product. However, after concluding the research, we are commercializing products from these pilot plants. We sell potassium, lithium, and this is also a merit in a large scale due to its lower capacity. Initially, the pilot unit capacity produced 40 tons. Currently, we're producing 200 tons of industrial scale lithium carbonate, 99% pure battery standard. A small quantity according to the market size, but the most important is that this production allowed us to enter the market. Today, our product is sought after and prized. This is important because when we start producing, we will achieve 15,000 to 18,000 tons. Sadly, whoever criticizes the project doesn't understand the difference between a pilot versus an industrial unit. As mentioned, we are currently consolidating the industrial phase.
My last question relates to the criticism that the National Center of Tauca has active participation in China in the research phase. They argue that this is a contradiction to the previously 100% state-owned research strategy of salt mining.
You can speculate about different topics and think up many things. In this case, that is not true. Tauca is located in the southwest of Coipasa salt mines, where we started researching the chemical nature of the salts in Coipasa. We equipped laboratories and housing for researchers and technicians at the Tauca Experiment Station. In 2013 to 2014, a Chinese company was interested in testing the potential of the Coipasa salt mine. At that time, the National Resource Management and the Ministry of Mines and Metallurgy agreed to allow the Chinese company to mine the product at their own costs and risks. According to the results, they agreed that there could be future talks to establish an agreement to work together. Finally, we did not reach an agreement, and they did not invest or mine there because of a controverted clause, which established that if there were highly positive results for potassium and lithium, they would be in charge of mining Coipasa salt mines. We rejected this clause because it contradicts Bolivian mining legislation. Therefore, this criticism is completely unsubstantiated.
Thank you for all of this information. It's nice to have an update about lithium exploration in Bolivia.
This is a unique experience in Latin America. Chile and Argentina brag that they are one of the greatest producers of lithium, but that is extractivism, and we don't want that. We want to generate knowledge, value, and technological advancement. We compare selling a kilogram of lithium at approximately $20 per ton versus selling a battery. We must think that we are multiplying that value by 100. It took several changes to become YLB. By 2008, the lithium project was inaugurated in Lipi Loma, Rio Grande, in the Department of Potosi under the leadership of the GNRE, part of the Mining Corporation of Bolivia. By 2010, the industrialization was launched to fulfill the goals outlined at the Economic and Social Development Plan. In 2017, the Ministry of Energy and the Vice Ministry of Advanced Energy Technologies were created, and within this framework, YLB was born as the strategic state-owned company of Bolivian lithium deposits. Therefore, YLB replaces the GNRE, and Comibol is no longer leading the lithium project. By 2018, YLB becomes a corporation, has its own patrimony that belongs in 100% to the state under the responsibility of the Ministry of Energies. The YLB Corporation will be able to create affiliated and subsidiary companies abroad and at national level, according to its business management. According to the U.S. Geological Survey, lithium resources in Bolivia are around 9 million tons. The Uyuni salt flats in Potosi hold the majority of the lithium resource.
What is the primary function of the Vice Ministry of High Technologies in terms of lithium industrialization?
The Ministry of Energy was created as an institution in the area of nuclear and evaporitic resources, such as lithium. Our office supervises, monitors, and creates strategic policies in relation to these two topics.
How important is it for Bolivia to develop lithium?
Very, very important. The highest value added phase corresponds to the public-private association in which the Bolivian state is the main partner holding 51% and no less. It is important to capture cutting-edge technology. In this sphere, there is constant updates, in which is why we provided a very important system of research and equipment at the Uyuni Salar and La Palca. We want to be able to continuously update in order to remain competitive in the international markets.
Does that include training?
Yes, of course. And that includes increased management capacity, strengthening the Palca Research Center, 80% of which is new equipment. We are also building housing units and continually developing ties with international universities via scholarships paid by the Bolivian government. Also, we have grants from German universities to continuously capacitate our technicians in universities around the world and in Bolivian universities as well. We currently have several master's and doctorate students studying at European universities. This has started 4 years ago, and it will continue.
There are some political criticisms about lithium extraction and its impacts on social and environmental welfare. What can you tell us about this?
There were some opponents to the project, particularly from an NGO. However, they lack technical knowledge. They asked us for an interview where they asked about the extraction process. We explained that we initially adopted a process similar to what Chile implemented, but we quickly realized that the process was not applicable to Bolivia because it was too expensive due to the use of large quantities of lime. Besides, that process generated large amounts of calcium sulfate and magnesium sulfate muds. We quickly rejected it because of its environmental consequences and costs. Our technicians utilize little quantities of lime, which is also used in other products producing lithium sulfate. That is the proof that we rejected the use of chlorides, due to the higher costs and environmental impact. This NGO has maintained and reiterated that we are using the initial projects. However, anyone can visit our mines and verify that that is not true. That is not the case with other companies. We also utilize solar energy in the extraction process, which is also environmentally friendly. Also, we are using salt water and will build a water treatment plant to treat lithium. So, the water use is absolutely controlled and recirculated. The solid waste will be used to produce other products. The salar offers an emporium of resources and will also industrialize magnesium, or magnesium hydroxide. The Bolivian lithium industrialization in Uyuni follows 3 phases. Phase 1 is developed by Bolivian technical knowledge. This is the research and testing stage. It started in 2011 and has 100% state production participation. It includes 2 pilot plants. The lithium carbonate pilot plant started operation on January 2013. It begins with Uyuni salt flat exploration, drilling of wells, and studies. Once the depth and location of the highest concentration of lithium has been established, they proceed with the respective installation of the ducts and brine pumping towards the evaporation pools. At the evaporation pools takes place the separation of the different constituent elements of the extracted brine, obtaining sylvanite in the first instance for the production of potassium chloride. With the evaporation process, there is no other type of energy consumed, but the disadvantages are the time required for the evaporation and the weather conditions at the Uyuni salt flat. The process of separation of other elements continues until obtaining lithium sulfate, a raw material that is processed in the pilot plant to obtain lithium carbonate. That is an essential powder used for the lithium-ion battery production. The semi-industrial plant of potassium chloride started operation on 2012. Potassium chloride is obtained from the sylvinite extracted from the brine concentration.
Lithium extraction requires huge amounts of water. Is this threatening water availability?
The area where we developed this project is a semi-desertic region. The water we utilize comes from the Rio Grande watershed, which drains into the salt flat. This water is not for human consumption because of its salt concentration, and therefore we are not affecting wildlife and human activity in the region. For some other processes that require non-salt water, we had to dig a well, but this doesn't really affect the region because it is less volume than the water we consume from the Rio Grande River.
What volume approximately?
Less than 30% of the total consumption. We are designing treatment plants for purifying the underground water and to recirculate used water in the processes, optimizing the use of the resource.
How are you planning to control the residues?
The process generates residues of about 70% sodium chloride, but these residues are non-contaminants and do not generate acid substances or further problems for the environment. YLB wants to industrialize these residues or salts in Phase 3 of our industrialization plan. Another way to treat these residues is returning them to the salt mine, which will not create problems in the watershed.
In terms of safety, what are the norms and future plans?
Bolivia has a labor hygiene law, which dictates all the parameters to develop the industry. YLB follows these norms in order to safeguard workers' health, for instance, providing safety equipment, thermic clothing, and appropriate shoes. This accomplishes the norms of occupational health previous to starting working at the site. In parallel, we have medical personnel that monitors workers and an emergency system to evacuate in case of accident. YLB puts a lot of focus on worker safety and health.
Are there also trainings?
Absolutely. We are constantly updating and training in environmental and safety conditions, guaranteeing that workers know how to use machinery and personal equipment. Potassium chloride is the most used source of fertilization in the world. Chile and Brazil produce and commercialize potassium chloride. Argentina has extensive reserves and by 2018 is in the process of implementing industrial exploitation. The Uyuni salt flat in Bolivia has one of the most important reserves in the world, consisting of 2 billion tons. Without considering other salt flats like Coipasa and Pexa and the other lower salt mines. Phase 2 includes industrial production with the Bolivian technological process developed and improved in Phase 1. International firms can be in charge of construction and installation of infrastructure only. This Phase 2 will have 2 industrial plants, lithium carbonate industrial plant and the potassium chloride industrial plant. This phase includes complementary construction and installation of industrial evaporation ponds, pumping wells, infrastructure, freshwater supply systems, wastewater treatment systems, and independent electrical networks. The lithium carbonate industrial plant is 100% state-owned and will be operated by YLB with a 30,000 metric ton year capacity. The goal is to produce a battery-grade lithium carbonate of 99.7% purity. The potassium chloride industrial plant will have two production lines. First, of 350,000 tons per year, and the second line will be implemented according to the development of the internal and external market until completing 700,000 tons per year. Phase 3 is better known as the value chain phase, which can be done through association with national or foreign private companies maintaining the majority participation of the Bolivian state and respecting its sovereignty over its natural resources. This phase includes cathode materials and lithium-ion batteries manufacturing, residual brine industrialization, research centers, and trainings. On October 5th, 2018, YLB and the industrialization partner German ACI Systems officially signed the constitution of a joint company that will be in charge of the lithium hydroxide plant to produce cathodes and later lithium-ion batteries in about 3 years. The Colombian company Solar Data Lab was responsible for the final design constructions, including civil, electrical, mechanical engineering, HVAC, special gases, security, and firefighting of the Center for Research in Science and Technology of Materials and Evaporitic Resources of Bolivia. By the end of 2018, it is expected to be completed. The Development and Pilot Research Center, CIDYP, includes technology transfer and will be in charge of developing different processes, optimization, and the development of new or alternative processes for products that are currently not considered in the production chain of evaporitic resources from Bolivia. As it was described before, only for the high added value industrialization and residual brine processing is it allowed to have association contracts with national or foreign private companies maintaining the majority participation of the Bolivian state. 8 consortiums were interested in being Bolivian partners in lithium industrialization. 5 from China, 1 from Canada, 1 from Germany, and another from Russia. After intensive review of their proposals, on April 20th of 2018, YLB selected ACI Systems, a member of the ACI Group, as a strategic industrialization partner for the Phase 3 that involves establishing a value chain from the extraction of the raw materials to the finished product. The agreement covers an industrial plant for the production of lithium hydroxide based on residual brine, installation and manufacturing of cathode materials, and a battery complex of 8 gigawatt hours per year. The plan is to use renewable energies to decentralize power supply, which will enable batteries and cathodes to be produced ecologically. Products will be destined for the alternative energy systems in the European market, mainly for the German electromobility industry. Later, ACI Systems will identify and expand to other potential partners and customers. Also, environmental management, education, and training for Bolivian employees is part of the partnership. The German ambassador in Bolivia, Matthias Sun, has described the project as strategic interest for both parties. Besides the high-skill and low-skill employment generation as a result of the lithium project, it also has the following social projects. Energy. In Bolivia, miners in underground mining operations require lamps for their helmets. In 2015, together with the company Focos, the Lithium project has designed and developed the prototype as you see here, where the Bolivian lithium batteries are attached to a cable that will light the miner's lamp. This new option offers a lighter weight and size of batteries, making them more comfortable for the miners. Another energy application aims to install between 15 to 20 systems called solar lithium in different educational units in Bolivia. To support the state goal to universalize electricity services in rural areas up until 2020, there is a plan to serve more than 175,000 homes and 1,700 social infrastructure facilities through photovoltaic systems. In 2012, YLB community projects have been supported with the drilling of wells for drinking water in southwest Potosi communities. Also, indirectly, YLB provides road maintenance. Education. Under the Evo Morales government, Bolivia offers 100 scholarships for scientific and technological sovereignty, a program targeting Bolivian professionals for the strategic and productive areas of the country. In 2016, the Lithium Project promoted the higher education of 4 professionals, offering them scholarships for master's and PhD degrees in worldwide universities. Industrial safety and occupational health. Management exists in all the facilities where workers are provided with personal protective equipment based on the type of hazard and risks identified according to the regulations in force. At the Lippi complex in Uyuni, Potosi, technical staff work 24 hours a day with different shifts, 14 continuous days of work and 7 days of rest. According to some experts, Uyuni has the disadvantage of having a high magnesium content in relation to the lithium content of the brine, which can affect the technological process of obtaining lithium salts. Also, there is concern in the delay in the fulfillment of some initial objectives due to political reasons, and that Phase 1 production was very small compared to the designed capacity. Following is all the information we have in regards to the recent conflict in Bolivia.
Did the social and political conflicts that Bolivia experienced in November 2019 affect the Lithium project?
There were substantial changes, especially in regard to highly qualified human resources that were withdrawn. Many of them engineers with 9 years of working in YLB, with accumulated unique experience and specialized postgraduate training.
Why was the contract between YLB, the Bolivian Lithium State Company, and ACI Systems canceled?
During the 2019 October-November conflicts in Bolivia, the Supreme Decree numbered 3738 that created the YLB ACI Systems joint venture was canceled. In this decree, the association considered that YLB held 51% of the shares. The abrogation of the decree was demanded and requested by the so-called Potosi Civic Committee. So, in order to contribute to the solution of social and political conflicts in Bolivia, in October and November of 2019, the government abrogated the Supreme Decree. The Potosi Civic Committee's arguments, politically motivated, distorted the objective of the association.
Was that agreement beneficial to Bolivia?
Within the framework of Law 928, since the second semester of 2017, work has been carried out on the determination and evaluation of proposals for the establishment of a partnership between YLB and a strategic partner under the modality of Joint Venture Agreement Law 466, which allows the industrialization of Bolivian lithium from Uyuni salt flats to be completed, adding value through the implementation in Bolivia of a lithium hydroxide plant and other salts from the residual brine generated by YLB in Uyuni, also with a cathodic materials plant and a lithium-ion battery plant with a secured market. For this purpose, there were approaches from more than 15 companies from Australia, Germany, Canada, Chile, China, United Kingdom, Russia, Sweden, and Switzerland that showed interest in forming a strategic partnership with the Bolivian Lithium State Company, YLB, for the industrialization of evaporitic resources of Bolivia. Within the framework of Law 928 and the political constitution of the state, the minimum initial exclusive conditions that the strategic partner should meet have been the following. Majority participation for the Bolivian government, minimum 51%. Minimum implementation of 3 industrial plants in Bolivia: lithium hydroxide, cathodic materials, and batteries. Obtaining lithium hydroxide from the residual brine generated by YLB Corporation in the Uyuni Salt Flats. And lastly, a secure market to the sale of lithium-ion batteries. Based on these minimum conditions, a strategic partner selection process was carried out, and as a result of this evaluation, the German company ACI Systems obtained the highest score, whose proposal can be seen on the screen. As a result of the proposal of the German ACI Systems that was selected, and for greater operability of its implementation, it was deemed convenient first to form a mixed company for salts from the residual brine, to subsequently constitute a second one for cathodic materials and lithium-ion batteries. One of the main qualities of the company ACI Systems is that it has managed to articulate the German state and its electric automotive industry, which represents, or represented, a huge advantage of the market assurance for lithium-ion batteries to be manufactured to an industrial scale in Bolivia. Given the events that took place in the Department of Potosi and nationwide on November 2, 2019, in response to the requirement of the Potosi Civic Committee, unfortunately the Decree 3738 for the creation of the YLB ACI Systems joint venture was abrogated. For a better understanding of the meaning of the term residual brine, a descriptive scheme of the production model is presented, in which YLB Corporation was going to sell the residual brine to YLB ACI Systems for processing and use. The complexity of the residual brine requires a suitable technology for its processing, which allows the direct obtaining of lithium hydroxide and other derivatives. This technology should be provided by the German partner. However, the repeal of the decree and the immediate impossibility of processing the residual brine, unfortunately, it will have to be returned to the salt flat, at least until it has the appropriate technology that allows proper processing. Therefore, the YLB ACI Systems joint venture was highly beneficial for Bolivia.
Are there formal statements by the current government about the direction of Bolivian lithium industrialization?
So far, none officially.
What do you think will be the destiny of the industrialization of lithium with this transitional government and with the possible new government to be elected in 2020?
There is still too much uncertainty about possible plans in this regard, so it is better not to speculate.
Recommendations?
The industrialization strategy designed since 2010 should continue.